Hello everyone. So let us now proceed to the computation of the dip of the plane of the vein and also the bearing of the strike. So we've seen this figure before in the previous slides. So in order to calculate for the dip right here, so you will just use the tangent theta. Okay, so let's write that out. Tangent dip right here is equal to CD opposite over the adjacent, which is BD, right? Okay, so you can solve the dip using that. And then here at the bottom for the grade of the drift, you can just use rise over run. So CD all over AD. Okay. And finally, for the bearing of the strike, so the first thing that we need to do is we need to solve this theta, right? The value of theta. So tangent theta is equal to BD, which is the opposite, over the adjacent, which is AB. Once you get that value, you can then use theta is equal to tangent inverse of the same of the answer. So once you get theta, you can then subtract that value from the bearing of line AD, right? So once you do that, you'll get the this angle right here, which if this is the north direction as stated here, so this is already the bearing of our strike or the intersection of the horizontal plane with the plane of the vein. Now, this won't always be the case because there are different orientations of the vein. So it's important to understand how we got these formulas. Okay, so let us now proceed. Okay, so before proceeding, let's first define boreholes. So any narrow shaft bored in the ground, either vertically or horizontally, constructed for extraction of water or other liquid or gases as part of a mineral exploration, geotechnical investigation, and environmental site assessment. Okay, so let's say for example, this is our surface and we want to know the orientation or if there are minerals down below the surface. So we drill boreholes there. And let's say for example that we encounter a vein, and for those three points right there, we have different depths um, where the borehole intersected the vein. So you have coordinates for all of these points, and then you can measure also the depth where the vein was intersected. So the first step that we need to do is to create a 3D coordinate system um, in order for us to calculate for the bearing of this strike relative to a particular horizontal plane and also the dip of this uh, plane of the vein. Okay. So the first thing that we need to do is again is to set up a 3D coordinate system such that z-axis passes through the highest point C. So let's create that first. So as you can see right here, our z. So our point C here, let's draw it. Our point C here intersects the z-axis. Okay, so you set it up like that. And then another condition is the line connecting the highest two points here in B and C. So the line connecting them, which is this line BC right here, should lie on the YZ plane. So the YZ plane is this plane right here. So it should we should set up our coordinate 3D coordinate system like that. And then the last condition is that we need to choose the lowest point, in this case A, to lie on the XY plane. Okay, so this is the XY plane, and the point, this lowest point right here, lies on that particular plane. Okay, so to solve the strike, extend the line of the two highest points to the horizontal plane. It intersects the plane at point D. So if we do that, um, we get this plane right here. So this is sort of like a projection of the plane of the vein. Okay, so we have point D here intersecting our y-axis. Point D. Okay, so now this is now the our strike here, intersection of the plane of the vein with our horizontal plane. Horizontal plane that we defined, right, based on the lowest point A. And then we can also calculate the dip of this particular plane of the vein. Okay, so let's move on. Okay, so here are the different formulas to calculate for the bearing of the strike. Okay, so let's examine this figure right here. So our ultimate goal is to determine the value of this angle beta right here. Now, we have 3 points, right? We have 3 points, A, B, and C on the surface. And we know these distances here, these vertical distances. And also, for most of the problems, we are also given these um, the distances of these lines right here because in practice, you know the horizontal coordinates of A, B, and C, right? So those are our given. And then if you have that, let's say we already know this distance right here, and we can calculate these angles, the angles theta, alpha, and phi right here using the azimuths, given azimuths. So we also know that. And then once you get alpha, you can also calculate for the sigma by subtracting phi from 180. And then you can calculate also for this side using similar triangles. So you can use this triangle here and then also this triangle right here, this upper triangle here. You can use similar triangles to calculate for this one. And then um, once you know this angle, let's erase the others first. So once you know this sigma right here, once you know this side and this side here, you can then compute for this side right here using the cosine law. And after doing that, once you've calculated that side, you can then calculate for beta. Okay, so using beta, you can then calculate for the bearing of the strike. Okay, so we will do an example in the next video so that this will be made a lot more clearer. So I will see you in the next video. So thank you for watching.